Alright, so now we're going to take a look at the Platonic solids. So these are your solids that are formed by plates, right, or planes. Platonic solids have flat faces, basically. So tetrahedron, that's just made up of 4 equilateral triangles. Hexahedron is a cube, 6 equal square faces. An octahedron has 8 equilateral triangular faces. A dodecahedron has 12 regular pentagonal faces, and an icosahedron has 20 equilateral triangular faces. And if we were in person, I actually have some of these in dice form. I have the octahedron, a hexahedron, which is just a cube, of course. I do have an icosahedron as well. I have one that's got 60 sides that are all the same too. It's crazy. But unfortunately, we're not in person right now. That's okay. So here's how to find area, surface area specifically, and volume of all of these figures. So anywhere you see a P, that's talking about the perimeter of the base. Anywhere you see a T, that's talking about total surface area. V is volume. B is area of the base. And that is specifically to a capital B. H is the height of the solid. L is a slant height, and that only occurs on either regular pyramids or cones. Well, pyramids and cones, not just regular pyramids. And then R is radius, of course. So let's take a look at our first one. This next one we're going to look at is going to be a cone. So keep those equations in mind when you look at the next problem here. So here we have a cone that's giving us the height, the slant height, and the radius. We want to find surface area and volume of this cone. So for surface area, they use T. I like to use SA just because that's what surface area is, right? It's S and A. The formula we had on that last slide is pi RL plus pi R squared. Again, L is the slant height. So let's label those in the picture. So this is our L. This is our R, and this 4 inside is our H. Notice we don't have H yet, but we will use it for volume here in a minute. So for surface area, we have everything we need. So we're going to go ahead and plug everything in. So it's pi times our radius of 3 times our slant height of 5 plus pi times our radius of 3 squared. Now, there's a couple different ways you could give answers. It doesn't say whether you want the rounded answer or not. So we're going to give exact answers and then round to the nearest tenth as well. So 3 times 5 is 15. So the first one is just 15 pi. And 3 squared is 9. So that's 9 pi. We can add these up. We can treat pi like it's a variable. So our surface area is 15 plus 9 over 24 pi centimeters squared. That is a perfectly suitable answer. It's actually called the exact answer. But now if we want to plug this in and round, pi, remember, is an irrational number. So when we do plug that in, 24 times pi comes out to be 79.4 centimeters squared. So that is our rounded answer. So now let's take a look at volume. So for volume, the equation is 1/3 pi r squared h. And we have everything again labeled in our picture. So our volume is equal to 1/3 pi times 3 squared times our height of 4. So we got a lot of multiplying to do here. So we're going to leave the 1/3 as is for now. And really we're going to just expand out the square, right? Because 3 squared is technically just 3 times 3, right? And then we're also multiplying by 4. I did that for a reason, because we have this 1/3. Technically, we can just get rid of the 1/3 and one of the 3's, right? Because 1/3 of 3 is 1. So now we just have 3 times 4. That's 12. So this is just 12 pi centimeters cubed. Again, that is our exact answer. But if we do want to go ahead and get a rounded answer, it doesn't tell us in this one. Typically, it'll tell you. It comes out to be about 37.7 cubic centimeters, or centimeters cubed. And there you have it. Let's take a look at our next problem. And you'll have one similar to this one in a minute. So this one here is Mike creating a mailing tube, which can be used to mail posters and architectural plans. The diameter of the base is 3 3/4 inches, and the height is 2 2/3 feet. We want to find the amount of cardboard Mike needs to make the tube. So it doesn't tell us what units to use, but we have inches and feet in this problem, so we need to make some adjustments. And I'm going to go ahead and say to use inches. So our diameter of our base is 3.75 inches. And then the height is equal to 2 2/3 feet. And again, to get that into inches, there are 12 inches in a foot, so you just multiply by 12. So 12 times 2 is 24. 2/3 of 12 would be 9. No, sorry, 8. So 8 inches plus the 24 inches gets us 32 inches. So now we have everything in inches. We're ready to go ahead and do our calculations. We do need our radius, though, not our diameter. So that's 1/2 of the diameter. 3.75 divided by 2 is 1.875. So now we're really ready. And it just wants us to find surface area, right? We don't need to know volume of it to know how much cardboard he needs. We just need to find surface area. And surface area of a cylinder is going to be 2 pi r times the height plus 2 pi r squared. So that's 2 pi times our radius of 1.875 times our height of 32 inches plus 2 times pi again times 1.875 squared. And really at this point the easiest thing to do is just plug it in the calculator and get our answer out. And again, since we are using pi, we are going to round to the nearest hundredth this time instead of nearest tenth. 399.08 square inches. Now we could actually do some simplifying, but again, because we have pi and we have these long decimals, wouldn't be any easier than just plugging in the calculator. The next one is for you to practice, and then you'll have your exit ticket. See you next time.